Hello and welcome back to the wonderful world of algebra. We're talking about properties of exponents. That's in chapter 6, section 1. Okay, we're going to start with this. I'm not going to get too much into reviewing. This is something you should already know. A repeated multiplication can be written using an exponent, like a to the third. Okay, we're going to look at fractions today. Okay, so if I do a fraction here, usually in the denominator we have a 1, so that'd be a over 3 to the first power. Okay, we can multiply anything by 1, so I would have a 1 up here. Those 1's could cancel out, so I could write that just as a to the third. Right, okay, so now let's repeat this. If I have, make sure you're writing all of this in your notes, very important, okay? 1 times a times a times a over 1 times a. Now I can write this as a to the third over, there's one factor of a down here, a to the first. Now I can also go back and I can cancel out 1a with this a. What I'm left with here is 2a's, so canceling out means like I'm taking away. So a to the third power, and I'm taking away 1, so minus 1 gets me a to the second power. Alright, now we take this again. And another example, 1 times all of these over 1 times a times a. I can rewrite that as a to the third over a squared. Or I can cancel out, I can simplify here. Simplify these, and as long as there's still something else there, I can cancel out the 1, otherwise I leave the 1. So that is also a times 3 and then minus the 2. So I'm left with only one factor of a, so a to the first power. Or I could put that over 1, right? That's all that's left, but we don't necessarily need this over 1. We don't usually write that if something's being divided or multiplied by 1. Now, if I take this same situation, and I'm going to divide by 3 factors of a this time. A times a times a. Then what I get is a to the third over a to the third. Well, if I divide anything by itself, first off I can say 3 minus 3 would be 0, a to the 0 power. But if I cancel these out, I cancel out all of these, right? All I'm left with here is 1 over 1. And 1 divided by 1 is 1. So a to the 0 power is 1, because anything divided by itself, if I have the same factors on top as I have on the bottom, I get 1. Alright, so make yourself a big note here. Anything to the 0 power is 1. So if I have 2 to the 0 power, 5 to the 0 power, 27 to the 0 power, or 342 to the 0 power. All of these. Alright, make yourself a big and bold 1. All of these equal 1. Highlight that, mark that. Anything to the 0 power is 1, because that means you're dividing by as many as you're multiplying by, because the exponents really just tell us what kind of multiplication is happening. Okay, now I can keep this example going if I have a times a times a over, let's say we keep that 1 there, times a times a times a times a. Now that's a to the third over a to the fourth. If I write it this way, 3 minus 4, what I get is a to the negative first. But if I just cancel these out, if I write what I'm left with, I have 1 on top and 1a, or just a to the first power, on the bottom. These two are the same expression. Alright, make sure you highlight that. Now I'm going to do another example because we confuse this and think, okay, that means the 1 goes up here because we have a 1 there. Nope. Okay, let's check that again. If I have 1 times A times A times A over 1 times A times A times A times A times A, then I get A to the third over A to the fifth power is equal to 3 minus 5. So that would be A to the negative second. If I go back and cancel these out, cancel, 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 the 1 stays up top, and I'm left with 2 in the denominator. So I have the 1 and then A to the second power. So a negative exponent does not change the sign of the base. It does not make the base negative. The negative exponent means we are dividing by more factors than we're multiplying by. So it is a fraction. And all of this is what's referred to as the quotient of powers property. Okay, if we want to have the product of powers property, then we will look at some products. So A times A times A, right, that's A to the third. And if I multiply that times A, that's A squared. I get 1, 2, 3, 4, 5, A to the fifth, right? Or I could also get that by saying these are 3 and these are 2, right? So that's 3 plus 2 equals A to the fifth, right? So if I had an example like 3 to the fifth times 3 squared, that's 5 plus 2, which would give me 3 to the seventh, right? Because here we have 5 factors of 3 and here we have 2 factors of 3. So in total, we have 7 factors of 3. Now that only works as long as the base is the same. You can't add if we have A to the third times B to the fourth. That is not A B to the seventh power. All right? No. The base has to be the same. So A and A. Can't have A and B. Okay. Now, if we had an example that was A squared to the third power. A squared means A times A. The third power means this, all of this that's in parentheses here, 3 times, right? So used as a factor 3 times. Now, I have 6 factors of A there, A to the 6th power. How can I derive 6 from the 2 and the 3? Well, 2 times 3 is 6, so that's a 2 times 3. So if it's a power to a power, we'd multiply those exponents. And the reason why is because it means I have this as a factor 3 times, and this 2 means I have that as a factor 2 times. So 2 times 3. If we have a power of a product like A times B to the third power, well, that means A times B times A times B times A times B, right? And that means we have 3 factors of A, 1, 2, 3. So that's A to the third power. And then we have 3 factors of B times B to the third power. So this exponent would apply to everything inside the parentheses. So that means A to the third power times B to the third power. And finally, we have the power of a quotient property. So if we have A over B and the whole thing, let's say to the second power, that means I have A over B, everything that's in parentheses, times A over B, right? And when we multiply, we go left to right. So that's A times A gives me A squared. B times B gives me B squared. So this exponent applies to everything inside the parentheses. So a squared over b squared, or if you want to do that with numbers, like we had the example we did in class 3/4. Oh, come on. 3/4 squared. That's 3/4 times 3/4, which 3 times 3 is 9. 4 times 4 is 16. Right? And we get that from 3 squared over 4 squared. That gives me 9 over 16. And there you have it, ladies and gentlemen. Lots of fun for everyone. That's properties of exponents. See you in the next lesson.